Now we're going to take a look at density A, the standard normal table that allows you to be able to figure out the area underneath your curve, or the percent of data that's underneath your curve to the left of a particular value for your z-score for any z-score, not just a z-score of 1 or 2 or 3. The 68, 95, 99.7 rule is kind of a quick idea that allows you to work it out for only those three values of standard deviations of 1, 2, and 3. Does not help you for other ones. So if you had a z-score of 1.5, it would not help you. So let's take a look at using table A here. If you had a z-score of negative 2.40, you would go on the left to negative 2.4, because this is your z-score to the nearest tenth. Then going across the top, you'd have to go to the nearest hundredth, which in this case is a 0. So you know your z-score answer will be in this row going across, this column coming down. In other words, it's right here. So if you had a z-score of negative 2.4, the amount of data that's to the left of that is 0.0028. Or if you had a z-score of, say, negative 2.46, you would want to go to negative 2.4, which we were on here already, this one right here. So you know it's going to be somewhere along here. And then, since your hundredth digit is a 0.6, which is this here, you got to go to a 0.6 in the top, which is here. So you know your answer is given to you right here. So let's go ahead and take a look at the next slide then. Your standard normal curve always tells you the amount of data to the left, or what's less than your z-score. Sometimes you'll be asked for what's greater than, and we'll deal with that in a little bit. But it always tells you what's less than. So let's take a look at that problem that we did before. What percent of women are shorter than 67 inches? We knew our z-score was 1. So on your standard normal table, you'd have to find a 1.00. So you go to a 1.0 here, which you know is this row right here. You got to have your hundredths digit being a 0. So you come down that one, and it's 0.4813. Now, when we did it before, we came up with 64%. However, your standard normal table is always going to be more accurate. Sometimes you're going to be asked to use your standard normal table to get a more accurate answer. Other times you'll be asked to use the 68, 95, 99.7 rule to just give you a general idea. So in other words, if we change this number into a percent by moving our decimal point over 2 places, we know that 84.13% of the women are shorter than 67 inches. However, what happens if you are looking for what percent of women were taller than? If you're looking for what percent of women are taller than, instead of this lighter area that we just found out of being the 64.13, we're looking for this darker area over here. But we know the total area underneath this curve is 1. So all we have to do to get this area is take the total area of 1 and subtract the area that we don't want, which we know already. So we'll go 1 minus 0.8413, which is 0.1587, or if we change that into a percent, 15.8% of the women are taller than 67 inches. So let's answer some questions. What's false about our standard z-score? Your z-score value has no units. And so that's the problem here. It says it has the same units as your variable. And your z-score is just the number of standard deviations you are above or below your mean. There are no units involved. So pause the video, read through this one here. Now, We're wondering for which graph represents what Marshall wants. In other words, is he looking for what's less than, or is he wondering what's more than? The key phrase is up here is he is interested in knowing what percent of SUVs is longer than his. That means greater than or above his. So that would be over here. So our answer is plot B because plot B is looking at the area above your z-score. So here, read through this. We have a score of 670, a mean of 600, and a standard deviation of 30. We want to know which one of these two is accurate for figuring out your z-score. Remember, your z-score is always your data value minus your mean. This one here is not right because it's your mean minus your data value. It's the first one which is right because it's your data value minus your mean over your standard deviation. Another way to look at it is since our data value is larger than your mean, you're farther to the right, so that means it's going to be a positive value. Which one of these two is positive? Well, it's only the first one. If your data value was smaller than your mean, then it would be negative. Now, your standard normal curve is symmetrical. So if you're looking for what's above a 2.33 or what's below a negative 2.33, it's the same shape, same area, because it's just the reflection of what was over here. For the most part, if you're looking for the area to the right, you take the total area, which is 1, and subtract the area that's to the left. And that tells you the area that's to the right. And your standard normal curve always tells you the area to the left. So whenever you're looking for the area to the right, you always go 1 minus what your table A gives you. So pause the video, read through this, try to work this one out. So we have a data value of 820, a mean of 1026, and a standard deviation of 209. We need to go ahead and find our z-score so that we can answer the question of what percent of students would be qualified, meaning greater than 820. Because if it's less than 820, you don't qualify. So you have to be at 820 or above. So you got to do your z-score formula, your data value minus your mean over your standard deviation, which we have here. Simplify the top. Go ahead and divide. You get almost a -1. So you got to go to your table A. You got to go to negative 0.9 on the left side. Find that row. Then you got to go ahead and find a 0.9, because that would be for this one here, going across the top. Find that column. So go across the row of negative 0.9 all the way till you get to the 0.9 column on the far right. And you'll see that that number ends up being a 0.1622, or approximately 16%. So about 16% of the people are to the left of that. But once again, we're looking for those that qualify, meaning above this 820. If this area is 16%, we need to figure out this area to the right. And that's the part that's shaded here. Once again, when you're looking for area to the right, you take your total area 1 and you subtract your area to the left. So you're going to go 1 minus what we just found out, and you get approximately 64%.